Hello students. So today discussion in this video is about physical and chemical changes. First of all, to start the discussion, what is a change? Like what is the meaning of a change? Student, there are many changes takes place in our day-to-day life. For example, weather changes, yes or no, seasonal changes, yes or no, day and night, yes or no, moon phases. So there are many changes constantly taking place. Raining, rain formations, cloud formations, sun evaporation because of the sun. So all these changes are not even that. For example, a tree is growing, a seed is germinating, yes or no, a leaf is falling, so a new flower bud is blooming. So all these are the changes. Milk converts into curd, curd becomes into more and more sour. So all these are changes only, students. So there are many types of changes. If you want to classify them, we can classify them like slow changes, fast changes, temporary changes, permanent changes. Some are desirable changes, undesirable changes, periodic changes, non-periodic changes. Like that, there are many types, we can classify them in so many ways. But when it comes to the chemical terms, students, there are mainly two types of changes where we have to concentrate. That is physical changes and chemical changes. So first of all, let us have the introduction. Whenever energy is supplied or taken out of matter, it always brings about one or other kind of changes. Like that means when energy is providing, how can you provide energy? By heating, by sunlight, or by electricity? Yes or no? When this energy is getting provided, something is changing, and that is like examples like heat of the sun causes evaporation. Evaporation is a change or not? Water converts into vapor. Water vapors are losing heat energy at higher altitudes, changes into clouds or snow. Again, these vapors are condensed to form the water droplets. That is a change. When electric current is passed through an electric bulb, its filament glows. That is a change by electricity, by the action of electricity. The milk sours quickly if not kept at low temperatures. Right? Milk converts into more and more sour in taste. Yes or no? The wood on burning produces large amount of heat and leaves ash behind. If you burn not only wood, anything burning, leaves behind ash and big smoke and heat energy is released. All these are changes or not, students? So definitely we need to classify them, and we have these main two classifications. One is called as a physical change, other one is called as a chemical change. So let us first focus on physical change. Physical change means, students, a change takes place. A change takes place when there is a change in physical state. Physical state means solid, liquid or gas to liquid to solid. That is called as physical. If physical state is changing, then physical change. If color is changing, melting points, boiling points, densities, solubilities, all these comes under physical changes. When we have to consider a physical change, a change takes place by changing physical state, color, densities, melting points, boiling points, everything, solubilities, all these comes under physical changes. But is it the correct definition? Is it the correct way to define? No. Why? Because you have to mention one thing, that is all these changes may or may not takes place, but one thing is not changing, that is chemical composition. That means chemical formula is not changing in physical change. It can change color, it can change melting point, it can change densities, it can change magnetic properties, solubilities, everything will change. But what is not changing at all? Chemical composition of matter is not changing. Chemical formula is not changing. That change is called as physical change. Maybe not every time a color may not change, not every time magnetic properties may not change, but one thing perfectly never will change. What is that? Then only we have to call that change is a physical change. What is that? It never changes. Chemical formula. Sir, what happens if chemical formula changes? That we'll discuss in chemical changes. Okay, got the clarity? For example, students, ice by providing energy converts into water. By providing more energy converts into vapor. Ice to water to vapor. Like, what is the formula of water? H2O. What is the formula of ice? H2O. What is the formula of vapor? H2O only. Is the formula changing? No. The formula is not changing, students. Then what is changing? Energy is changing. Yes or no? Physical states are changing. Yes or no? That change is called as physical change. So we have some examples to discuss, and we have the general characteristics of physical changes also. Everything we'll discuss. Let us start. Production of sound when two materials are hit together. Okay, a sound is getting produced, students. A sound is produced. Is it a physical change or chemical change? Like any new substance is getting produced there? Absolutely no. Yes or no? Then that is definitely a physical change. So expansion or contraction of metals on heating. Have you seen in the railway tracks also, between the rails there is some space is left? Yes or no? Why? Because during the summer season metals expand. So for the free expansion, that space is, they kept that space. So when these metals are expanded or when they contracted, is the formula is changing? Is the metals are changing? Are the metals changing? No. Expansion or contraction doesn't change the chemical formula. So that is definitely physical change. Yes sir, simply atoms are expanding or molecules are expanding or they contracting. Depends upon the energy. So that's a physical. Evaporation of water by the heat of the sun. Evaporation. What is evaporation? The surface water molecule slowly, by getting rid of the intermolecular force of attraction, by gaining the energy, escape into the air, atmosphere, right? That is evaporation. So these water molecules, when they escape to form vapor, here is H2O, there also H2O. What is the difference? Energy is the difference. Understood, students? Intermolecular force of attractions are different. Intermolecular spaces are different. Yes or no? But formula remains same. So evaporation is also a physical change. Condensation of water vapor, such as formation of clouds mist. Again, these vapors, when you condense it, that means under the conditions of low temperature and high pressure, they converts into water. Like, is the formula changing? No, the formula is not changing. If the formula is not changing, then the change is physical change. Formation of solutions of soluble substances in water. Okay, add salt in water. Now answer, is it a physical change or chemical change? If you add salt in water, students, does it form any new substance? Sir, the salt water is produced, na? Some students have that. Salt water is produced, correct, that's salt water. But still there is salt inside, there is water in there, yes or no? If together they combine and they produce any new substance? No. What is the proof? Boil it. Then what will happen? Water will evaporate, leaving the salt behind. That what does it mean? Salt is there still. Is it chemically reacting? Any new substance formation? No, nothing else. Simply the salt molecule getting into the spaces between the water molecules. That's it. Salt is there, water is there. That is physical. Solubility also comes under physical changes. Melting of ice or wax or butter or ghee. Melting. Melting means conversion of solids to the respective liquids. That is melting. Okay. Melting of wax, solid wax, liquid wax. If the formula changes, hydrocarbon changes? No. Melting of ice, formula changes, H2 only. So that is also a physical change, students. We have some other examples. Freezing of water to ice or solidification of liquid wax to solid wax. Opposite process. That means melting is physical process. What about freezing? Also physical process. Like liquid converts into solid. Yes, sir. H2O, H2O. The changing of water into steam by boiling. By boiling, water converts. Have you seen the pressure cooker? You know, the fumes, the vapor coming out, which is very hot. That's the difference between vapor and steam, which is very hot. That is steam. Yes or no? Now, what is the formula of that? That vapor, H2O only. Yes or no, students? But with a high energy. So that steam production is also physical change. Glowing of an electric bulb or the passage of electric current. By passing electric current, the bulb glows. When you switch off, again it will be off. Yes or no? Is any new substance getting produced in this process? No. Got the clarity? So that is a physical change. Crystallization of salts from their solutions. Okay, crystallization means from the solution of the salt, getting crystals of solid crystals of the respective solute. That is crystallization. So for example, salt in water, the salt gets crystallized. In water also, in the solution form also it is NaCl only. In crystal form also it is NaCl only. Is the formula changing? So melting. So this process is also physical changes. So change of color due to the heat, as in the case of zinc oxides or lead oxides. So when the color is getting changed by heating, sometimes color changes by heating also. Why? Because color is mainly based on structure of the molecules in which they emit the light energy in a particular wavelength. Yes or no? So because of the structural changes, sometimes color changes. If the color changes, ultimately the molecular formula is not changing. Yes or no? So definitely that is also a physical change. But remember, students, the main point: color changing, physical states changing, densities, solubilities, everything. In all these cases, we are calling it as a physical change. But don't forget one point out. What is that? All these changes takes place for may not takes place for all the examples, but one thing is for sure, it doesn't take place. What is that? Chemical formula is not changing. Then only that change is called as a physical change. So let's see some of the characteristics of physical changes. No new product is formed. Yes or no? Any new substance is getting produced, any new chemical formation takes place? No. Then that change only called as a physical change. The change is temporary and reversible. We can reverse the change. But students, here one point, not all the physical changes we cannot reverse. We have to discuss about this point. For example, tear a paper. Can we reverse it? Don't think like, sir, we can glue it. No. Can we get the original? No. Cut a piece of wood. Can you reverse it? Take rice grains and powder it. Can you reverse it? Break a mirror. Can you reverse? So, got the clarity? In general, they are temporary and reversible, like conversion of solid to liquid to gas to, that is okay in general. But there are some examples which there are some physical changes which we cannot reverse it also. Just keep this point in your mind. But according to the syllabus, you have to follow this statement. There is no gain or loss of energy, which means, students, the amount of energy which is required for that change is the same energy it releases when you opposite the process. And it means, is there any change in the net energy from that substance? No. Got the clarity? So there is no gain or loss of energy. You are providing external energy. If you reverse it, that same energy will be released. Got the clarity, students? There is no change in the weight of the substance, correct? Weight of the substance also, there is no change. H2O, solid, liquid, gas. Sir, solids, liquid, gas means solids have more weight. Na? You have to take a particular quantity, students. Take 10 grams. That in ice also 10 grams, in vapor also 10 grams only for sure. Maybe that expands. Yes, no, students? Vapor will expand. But formula changing? No, formula is not changing. Got the clarity? H2O, anywhere H2O only. Two hydrogens and one oxygen. Hydrogen atomic mass is 1 gram, oxygen atomic mass is 16 grams, altogether 18 grams for 1 mole. Right, next, these are the characteristics of physical changes. Some of the experiment, students, for example, wax converts into molten wax. How? By heating. Yes or no? What is happening when you heat? You know what is happening? These molecules are having these intermolecular attractions are there, students. These attractions will be broken and slowly it converts into liquid state. That simply it is expanding. If you cool it again, what will happen? Again it will contract, come back to the normal position. Again it develop intermolecular attractions, as converts into solid. So this is the reversible process, which is a physical change. Solid wax to molten wax. Again, when you cool down, molten wax forms the solid. Heating of zinc oxide. In zinc oxide is white in color. If you heat it, it becomes yellow color. But look at the formula. ZnO. What is the formula here? Here also ZnO, but color is changing. Why? Because structural arrangement of these ions are changing. So that's why color is changing, but the formula is not changing. Right. Next, chemical changes. You already have an idea about chemical changes. So students, chemical changes. You already have an idea about physical changes. Yes or no? What is a physical change? A change takes place by changing the physical state, color, taste, order, densities, magnetic properties, solubilities, physical change. But one thing is not changing. What is that? Chemical formula is not changing. Which exactly happens in chemical change. So what are chemical change? A change takes place by changing the chemical formula is chemical change. That's it. What is a chemical change? A change happens by changing the chemical composition of the substance. In this process, the main point, remember students, during the chemical change, physical states may change, color may change, densities will change, melting points, boiling points, solubilities, magnetic properties, all will change, may or may not change. They change. So, sir, color is changing now, so definitely it is physical. No, you have to check chemical composition. Along with that, if chemical composition is not changing, physical only, but color is changing, but chemical composition also changing, means it is a chemical change. Sir, physical state is changing, so every time it is a physical change? No, you have to check the formula, chemical composition. Physical state is changing, chemical composition also changing, then it is a chemical change. I will give an example. Hydrogen gas, it's a gas. Oxygen gas, it's a gas. They combine chemically, they produce a new substance called as H2O, which is a liquid. So previously we have gases, now we have a liquid. Can we say it is a physical change? No. Previously we have hydrogen gas H2, oxygen gas O2. Now we have H2O. What? Water. Yes or no? New substance or not? That is called as a chemical change. Change which alters the specific properties of a substance by bringing about a change in its molecular composition, by creating new chemical bonds, by breaking the old bonds. A new substance is getting generated, followed by a change in its state is called as a chemical change. These changes are permanent in nature and cannot be reversed. Such changes are called as chemical changes. Okay, we'll talk about this point in the coming slides. So, students got the clarity about chemical changes. A change takes place mainly for what reason? By changing the chemical composition. By changing what? Chemical composition means formula of water is H2O, that will be changed. Then it is a chemical change. Everyday examples of chemical changes. Rusting of iron. Rusting of iron, yes sir, no, iron in general, what is the color of iron? Silver. Rusting, if you keep the iron articles for so long outside and everywhere, like even sometimes our nails also which are present in the doors, they will become brown in color, yes sir, no, what is happening there? Iron converts into iron oxide, that is called as rust. Which is iron, that is it still iron? No, it is iron oxide, Fe2O3. That is a chemical change. Cooking of food, you answer guys. Cooking of food, is it a physical change or chemical change? Cooking of food is a chemical change. Why? Because I'll give you one example. Students, definitely there is a difference between eating raw vegetables and cooked vegetables. Yes sir, what's the difference? Cooked vegetables or cooked anything easily digestible. Yes sir, no? Comparatively with the raw food. Why? The reason is, students, when you cook the food, what happens, you know, the particles, the molecules, the higher members of proteins, vitamins break down into simpler proteins and simpler vitamins. That means a molecule is getting broken down or not? Then that's why it is a chemical change. Curdling of milk. Milk converts into curd. Yes or no? Is it a physical change or chemical change, students? Curdling of milk is a chemical change. Why? Because which is easily digestible, milk or curd? Curd is easily digestible. Yes sir, no, by the action of lactobacillus bacteria, the same process is happening. The higher members of proteins are broken down into smaller member proteins. So that's why curdling of milk is a, what happens? It's a chemical change. Milk is like light sweet in taste. Yes sir, no? Curd, is it same sweet in taste? So taste is changing, it's a physical, okay. It converts into, if you keep that curd for so long time, it will become more sour in taste. What does it mean? Acid becoming is more, yes or no? The production of acid is getting more. That means new molecules are getting produced or not? That alters the taste, yes or no, students? That is a chemical change. Ripening of fruits, this is also the example, same. For example, green mango, yellow mango. Now what are the tastes? Taste of green mango, sour in taste. Taste of yellow mango, sweet in taste. So taste is different, so can we call it as a physical change? No. Acids converts into sugars. Acids converts into sugar. Is it a physical change or chemical change? It is a chemical change, students. That's what. So germination of seeds. A seed is getting germinated, converts into a tree. It is getting blooming, flowers. All these are physical or chemical? Chemical. Sir, it is small, like getting big. Is it physical? No, not that way. Chemical reactions are happening. So blackening of silverware. Silver converts into, for the long use of silver, it converts into black on the sides, edges, yes or no? Why? Because of the production of silver sulfide. Production of silver sulfide, which is a chemical change. Fading of colors of the clothes, yes or no? Dyeing process. These colors form complexes with the fiber. So over the long use, what happens? The colors will be gone, and the complex, by the molecular level, the complex will also be weakened. So that's why it's a chemical change. Decaying of old pieces of wood. Wood converts into, over the long time, it becomes into soil, yes or no? Slowly. Why? Because of the action of the small insects and all the bacterial fungus growth. What happens? They eat away the food particle and they excrete all the other substances. That means a new substance is getting generated. Decaying, not only wood, anything is a chemical change. Food turning bad after few days. Yes or no? Food getting spoiled, rancidity. That means the food converts getting into oxidized. Cut an apple, expose for some time, it will become brown. Why? Getting oxidized. So this spoiling of food also comes under chemical changes only, students. Digestion of food within our body. Yes or no? During the digestion, what is happening? The food, the energy getting separated and just it transported throughout our body or not? It converts into breaking down of molecules happening, yes or no? The digestion process. So that is a chemical change. Fermentation of sugar solution to alcohol. Sugars converts into alcohol, means in the directly it is a chemical change. Hardening of cement to form a concrete block. Cement, normal cement, by the mixture of some water and sand, we can make a concrete block out of it, yes or no? What is happening? At the molecular level, they becoming attracted and they form a new complexes, which is a chemical change. So respiration by humans and plants, and respiration, right? Taking oxygen, releasing carbon dioxide. Burning of wood, coal, kerosene, petrol, liquefied, LPG, not only anything, burning anything in general, what is happening? They release new substances. What are the new substances? Carbon dioxide, SR9, H2O, mostly hydrocarbons, combustion reactions. So a new substance getting generated, SR9, burn paper. What happens? Energy is released and ash. So it is a chemical change. Lightning of matchstick by striking a match, that is also a chemical change. It contains antimony sulfides and all, so it converts ignited and they converts into the respective other chemicals. So which is burning in general, chemical changes only. So what are the characteristics of a chemical change? Let's see. A chemical change results in the formation of at least one or more new products. What happens? One or more new products. Definitely a new product should happen. Synthesis of new products will happen. That change is a chemical change. Heating of sugar, an example is given. When the sugar is strongly heated, what is happening, students, in the test tube? When the only sugar is strongly heated, what happens? The water, whatever the particles present in it, will be gone and it becomes black. Yes or no? That means that remains pure carbon. All the bonds will be broken, everything will be gone. It melts, it gradually changes to brown color. Yes or no? We also use that mixture for sweets and all, but that is not the end. Over the long heating, giving a large amount of steamy fumes, in the end black mass is left which consists of pure carbon, students. So that is a chemical, a new substance is getting created anywhere. A weight of the substance undergoing chemical changes usually changes. Here there is one point where students will confuse. Students, in chemical changes also mass will never change. Before the reaction, after the reaction, mass is same. Law of conservation of mass. Matter can neither be created nor destroyed. Okay, but what is the meaning of this point? Weight of the substance of chemical changes usually changes means, for example, magnesium 24 grams converts into magnesium oxide, which is 40 grams. In that sense, that means one substance converts into a new substance, right? When you compare between these two, definitely there is a change. Yes or no? Of course, in a balanced chemical reaction, both sides are equal only. But if you consider only this chemical and this chemical, definitely there is a change. H2, H2O, just compare. Yes sir, no change in mass, that's what the point says. So weight will changes, but ultimately the reaction, a balanced chemical reaction, mass always remains same, remember. So chemical changes is permanent and reversible. This point we have to discuss. So chemical changes are permanent and reversible. In general, sugar, strong heating to form carbon. Can we get again sugar from that carbon? No. Carbon dioxide and steam formed during the burning of candle cannot be converted into wax by altering the conditions. Burning candle converts into carbon dioxide. Can we convert into candle again? No. Burning anything, burning paper, burning wood, can we convert the can we reverse the reaction? No. In general, explosion, burning reactions, precipitation reactions we cannot reverse, students, but there are some reactions which we can reverse also. You should know this point. For example, production of H2O, we can reverse it into H2, hydrogen gas and oxygen gas. Yes or no? Electrolysis reaction. Production, decomposition of calcium carbonate, again converts into CaO plus CO2 is raised to calcium carbonate. Opposite process. Production of ammonia and decomposition of ammonia into nitrogen and hydrogen gas. Some chemical reactions can also be reversible, but according to the syllabus only this point is given, just follow that, but have that idea. Lot of heat is usually given off or absorbed during the chemical changes. Here students, lot of heat energy is released means chemical reactions are two types in terms of energy: exothermic reactions, endothermic reactions. Exothermic reactions means the reactions takes place by releasing the energy, exothermic, and the reactions takes place by absorbing the energy, endothermic. So two types. So depends upon the nature of the bonding, depends upon the conditions in which they takes place, these reactions occur. So experiments, burning of candle, yes or no? Hydrocarbons burning produces carbon dioxide and H2O. Is this chemical change or physical change? Chemical change. But look at here, some wax getting melted. Is it physical change or chemical change? This is physical change only because of the heat energy, wax getting melted. We are not talking about that. The liquefied wax converts into smoke. That means carbon dioxide, yes sir, that is chemical change. Burning of mercuric oxide, red mercuric oxide converts into this mercury and oxygen gas. Look at the reaction, decomposition reaction, yes sir, no. Of course color is changing, but here color changes means, can you call it this as a physical change? No. Formula also changing, yes sir, no students. That's why it is a chemical change. So next, last one, rusting of iron. So before talking about rusting, we have to talk about corrosion, students. Corrosion means the upper surface of the metal or the exposure of the atmospheric gases getting corroded. That means the layer gets corroded. The layer converts into its respective oxide or sulfide or carbonate. That process is called as corrosion. And the corrosion takes place in terms of iron is called as rusting. For example, what is the color of iron? Silver color, yes or no? If you cut a normal iron. Or the exposure to the oxygen and H2O, what happens? This silver molecule slowly, is it a fast process? No, slow process. Slowly reacts with oxygen and produces iron oxide in the presence of water. Yes or no? That is rust. Fe2O3 dot XH2O, which is a water of crystallization, is called as rust. So both are same, iron and iron oxide? No, iron oxide is a flaky substance. Yes or no? So that is rusting, students. And what are the conditions for rusting? Presence of moisture, right? Water vapor, H2O, presence of air, which means oxygen. So these are the main two where the rusting happens. If only water vapor is present, no. Only oxygen is present, no. Definitely both should be the essential components for the rust. So like, is this rusting good or bad? Absolutely, rusting is not good. Why? Because in our in general infrastructure, in general in our daily life, our main component, main metal is iron only for buildings or bridges everywhere. Yes or no? For towers. Then if a bridge was constructed and it gets rusted, what will happen? The strength of the iron will be reduced. Yes or no? It will collapse. It will collapse. Got the clarity, students? But we want to avoid it. How to do it? Like how to increase the lifetime of the iron? We can paint it. Yes or no? If we can paint it, is it exposed to the oxygen and water vapor? No. Window grills and all, students, are they pure iron? No, they are painted. Yes or no, students? So why they are painted? If we painted the inner iron, is it exposed to the oxygen and H2O? No. But when it comes to the bridges and many big things, painting is not a good idea. Why? Painting and greasing is not a good idea. Why? Because, students, over the long time, even the paint also falls off. Yes or no? Even if you want to paint the whole bridge, it's not a simple thing, right? So instead that, we have a process called as galvanization. That means coating iron with another metal, like mostly with zinc. That is called as a galvanization. Have you seen the railway bridges? What is the color? Mostly white silvery color. Yes or no? That is galvanization. Inside, that is not pure zinc. Inside iron is the outer surface is zinc. Now it is long time or not, long lasting or not. It's not like a paint. That process is called as galvanization. It is considered as the best method to prevent rusting. It is the process of deposition of thin layer of zinc on iron surface. It is done to prevent the rusting. That is for long time process is called as galvanization. Application of a coat of a paint or grease on the surface of iron also helps us prevention of rusting. So these are the techniques to prevent rusting, students, which helps us to increases the lifetime of the iron. So that's all about this chapter, physical changes and chemical changes. I hope you got the clarity about what is a physical change, what are the characteristics, examples. Same for chemical changes also and rusting. And this chapter is completed. Thank you, students.